This is the Amp Hour Podcast, recorded August 19th, 2012. Episode 109, with guest Larry Sears, Hexagram, Hardware, Holism.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of ChipReport.tv.
And I am Larry Sears. I'm an adjunct lecturer at Case Western Reserve University.
Welcome to our first in-studio guest ever.
Welcome, Larry. Thanks for joining us. This is great.
My pleasure.
And you're in Chris's dungeon there.
That's right. That's right. But there's a little bit of light filtering through, so our eyes haven't grown over yet.
Yeah. Yeah, well.
You haven't turned into a zombie and you're not going to eat Chris.
And I'm used to basement. I'm used to basements. We're all used to basements.
Yeah.
Cleveland, engineers, yep.
Engineers
that's where we live.
Right. Yeah. Yeah, so...
If you basically have sunlight, you're a manager, aren't you?
I think that's what happens, right, exactly.
Right, yeah.
Right.
And actually we do that at work, too. We say, doors and windows, if you get a door and a window, that means you have a position of power, right?
Right, as opposed to a corner office, which is beyond your imagination.
Oh, well, yeah. But otherwise it's cube, it's straight, burlap or whatever they put on the cube walls these days.
Cubes are going out of fashion.
True.
Cubes are disappearing.
That's true.
It's the back to the open office, and I wonder where people go to pick their nose. I think it'd be a little bit distracting.
Or watch their, YouTube videos
that's right.
and stuff all day.
Yeah. Well, someone's got to be watching you, right, Dave?
Yeah, right.
Yeah.
See, there was a noticeable drop in productivity during the Olympics.
Really?
Yeah.
Oh, I didn't hear about that.
Yeah.
Right.
Affected the GDP. Yeah.
Wow, there you go.
NBC sure didn't pick it up either.
No, they don't want it.
So, Larry, you're going to tell us all about your history, how you formed a company, and then we're probably going to get on to education.
Okay, that would be fine. That would be fine. Excellent.
Because they're your two big things, right? You've tell us. Let's start with what you're currently doing now, and then we'll jump back in our DeLorean back to 1972.
All right. Well, I just like to make things. That's probably where it all started. And at the present time, I teach a circuit design course at Case for juniors and seniors, and it is pretty much analog design and mixed signal. It's the only thing I know, and that's what I'd like to think I do best, and I enjoy it a lot. It's a project-oriented course, so the project of the week will be make a function generator or make a motor that regulates its speed with an encoder input, and they have a week to do it, and that's the way the project is taught. So we'll talk about a particular topic. It might be analog switches, for example, or something, and then the project is based around using those particular components. And we have a great lab and lots of neat equipment. They probably won't see that equipment when they go out to get a job, but just the same, it gives them a good introduction to to the engineering world. And I have a lot of fun. I really enjoy it. In fact, when I graduated from Case in '69, I actually did this for a few years when I started my company, and then 35 years later or so, I after I sold the company, I went back and did it again. So I'm having a great time.
It's good full circle.
Yeah, and it fends off the Alzheimer's.
So you're purely an analog guy? You don't do that evil digital stuff, or heaven forbid, software?
Right. When I was an undergraduate, I did punch cards and algol. And that's enough to turn anybody away.
This is in the days in NASA, right?
Yeah, well, yeah.
Of the moonshot.
Oh, that's right. Yeah, that was a big thing, right, 69.
What were you doing when the moonshot, how did you watch the moonshot?
On the TV we pulled out of a garbage can. And, it was really amazing. Of course, I like to look, I'm very interested in historical technology also. I like to look back at the fact that the way I understand it was they were given a cubic foot. And they said, this is your bay for the computer. And that led to, I think it was DTL or something, and all that stuff. And they started with a cubic foot.
Wow.
And they had to fit their...
Mechanical guys always get to define it.
That's right.
Every time.
Well, and they probably had a weight requirement,
Yeah, that's true,
and
too.
probably a power requirement.
Yeah.
But
there's a book on that. I downloaded the sample from the Amazon Kindle store, how they designed the Apollo flight computer.
Oh, that would be interesting.
And there's a whole book on it. I haven't bought the whole thing yet, but I've read the sample of it, and it sounds interesting.
Yeah.
So, I don't know who wrote it. But
I'm interested in I'd love to get, like, the guidance system from a Nike missile, you know?
Yeah.
With probably 3-volt vacuum tubes or something. That would be great to have.
Yep.
Right. Yeah.
And all sorts of analog.
Oh, yeah.
It'd be all. Would it be all analog?
The guidance systems, the guidance systems of the heat-sinking missiles were certainly analog. In fact, there's an interesting story. They were going to build they knew how to build a heat-sinking guidance system. And they were like, this was back in the 50s, and in 50s dollars it was going to cost, I don't know, say $100,000 a missile. And some guy said, that's ridiculous. I could do it with what was called, what the All-American 5 is?
I have one right
here.
actually.
Well, or in your case, Dave, it was the All-Australian 5.
Right.
That was a tube lineup for the 5-tube radio.
That's right, yeah.
With every tabletop radio used the same tubes. And so this guy figured they made them in such large quantities that he would use some of those tubes.
Yeah.
And he did this thing for like $50 on his kitchen table. And they actually did use the design.
Really?
And by the time they were done, it was $10,000, but it was still like 10% of what it was supposed to cost.
Yeah.
And he used those vacuum tubes.
Right.
And just looked at it as from a manufacturing side.
That's
rather
brilliant.
than
I'm curious as to
military
for
side.
someone who hasn't worked on valve stuff, especially in that sort of environment, how would you get a fragile glass valve to survive in something like a missile?
Well, it didn't have to last,
vibration
didn't have to
would
last
be...
very long, did it?
Oh,
Right.
well, no, it doesn't, right? It only has to last a couple of minutes.
Short warranty.
Right? Yeah.
Well, that's a good question. They did have metal vacuum tubes.
Really?
Yeah, remember the old black metal military vacuum tubes?
Never saw those.
Yeah,
Okay.
they were, sort of like we had JEDEC. They had certain military numbers on them. But,
So they would be designed for high vibration, high shock environments.
That's where the hearing aid vacuum tubes, remember what those looked like?
No, I
They
haven't
were
seen
really
that.
tiny
little
ones,
tiny, almost
Yeah.
like Christmas tree lights.
Yeah.
Those were developed for fuses.
Really?
And what the military thinks of as a fuse is a little radar set that goes in the nose of a artillery shell.
Oh, right, yep.
And that 50 feet away or something, it would detonate. And that's how they developed those tiny little tubes. And I imagine they had, just like automotive bulbs, they probably had very rigid filaments.
Yeah.
So, it's interesting to see how those developments are. There's so much is prompted by the military, as we all know.
Yeah.
So, it's interesting to look back and
you see those kind of popping up these days with a lot of like surplus projects because those were higher volume stuff. And,
Right. Yeah, that's right.
Yeah,
That's right.
That's fun.
Well, for example, a good example would be MEMS devices. Now you can buy a gyroscope for $4. Well, that's because they're using them in cell phones.
Right.
Or you can buy a GPS card for $15. It's amazing what happens, the joys of production.
We talked to Bunny Huang, who's a consumer electronics kind of guy, and he said he bought an iPhone schematic for $4 on the streets of Shenzhen, but he did it in order to get the parts list because he wanted to do the same thing. If Apple's buying it,
that's right.
There's going to be
parts,
lots of copies, right?
Give you stories when we talk about subcontracting along those lines.
Oh, really?
There's a real there's a real lesson there is to leveraging what people are making a lot of.
I do that all the time, and
It's sensible.
Somebody wanted to make, if you go to a bakery or an ice cream store and it says now serving,
yeah.
so there's this company that made them out of plastic flip cards or something, and he had the idea to make them out of LEDs. I don't know where this guy got the idea. So he said, listen, I think we can make these out of 7-segment display using LEDs. He said, but LEDs are $2 a piece. I've checked. He said, you really think this is worth doing? So everybody I've talked to said this is ridiculous because you need 36 LEDs or something, and they're $2 a piece. And I said, give it time. And so we made a prototype, and we did some testing and this and that. At that point, I still remember, they were about 35 cents a piece.
Just watching the slope, huh?
In a year, they had dropped from $2 to 35 cents. And then, of course, by the time we got in production, they were probably 10 cents.
Right,
So, hit your star to volume production, and you'll do just fine.
Exactly.
So.
Well, how about, can you take us back? I mean, so you got out of school, you started teaching for a little while, and then you decided to start up a company, and what was that all about?
Right. Well, again, since I was 4 years old, I wanted to make things. That's all there was to it. And I just loved to make things, and that's really was sort of my driver. I was really pretty fortunate, because most people, by the time they're 60, don't know what they want to do. Mm-hmm. So I was sort of driven by that, and I was just fascinated not only by electronics, but just by mechanical things and taking things apart, the usual. And so when I graduated, I had been very fortunate, because the faculty members had a lot of industrial projects. And so they were always looking for hungry undergraduates who could help them out in breadboarding and things like that. So I had great campus jobs, and they would send me out to these companies. So I worked for a little while for a company in a small town in Ohio, and that was not fun. So I decided I would go back to the campus, because there were more girls there. And
well, not a case though, right?
They had merged.
Right?
They had merged with the universities.
Right.
Anyways, so I was lecturing, and it gave me some time. I had lots of time, all night long, to build up what became a design and build business. And there's this neat little neighborhood known as Little Italy, which is right next to campus. So I had a storefront. The rent was $100 a month, and it was a great spot. You could have heavy floor, so you could have
drops,
a lathe, a lathe, and some heavy stuff. And so I decided I was going to make things for people. And my feeling was that there weren't electrical engineers like there are now. There were electrical engineers who were making, working for industry and things like that, but there wasn't a lot of the semiconductor industry isn't what it is now. You had big companies that had people, designing motors or something, or running conduit, but you didn't really have instrument designers, you didn't have control designers. So I figured there must be a lot of companies, especially in an industrial area like we were in, that would have products. An example might be vending machines, and they could use an electronic control. So I had this great idea that people would come to us. We would design controls using whatever, TTL, discrete logic, whatever, or maybe they might need power supplies or motor controls or something, and I would design these little circuit boards or modules, and they would buy them by the millions and put them inside their machines, and the world would be great.
Yes.
So it was design and build. There were also, at that time, actually not many, but there were certainly many in the next decades, stuffing houses. And that's, of course, was pre-surface mount, when you literally stuffed boards.
Right.
Yep.
And you stuck the parts, axial parts, whatever, into holes in the boards. So there were stuffing houses and design and build. I didn't want to be a stuffing house, because a stuffing house would get a blueprint, and you would build it to the blueprint, and that just seemed pretty boring. That was pure assembly. But design and build, you could offer a complete service, and at the same time, you would be able to utilize your design skills, which of course was my interest. I also felt we could be more competitive, because we could design products to use parts that we were using for something else. We already were buying them in quantity, and you could have families of products and all that, and cross-fertilization. It sort of worked that way. We started out, actually our biggest customer was General Electric, oddly enough, doing not production, but just one-of-a-kind
machine design kind of stuff?
No, some machine control, but mostly instruments. Things like watt meters. This was a time when they were developing the compact fluorescent.
Ah. So what year range was this?
This was like 1970 through 75, and high-pressure sodium lamps, which had very fast rise time, high-voltage pulse. We did a lot of high-voltage work, a lot of power supplies, some sort of optical regulating equipment, scanners and stuff. So it was wonderful work, because you really didn't have a lot of risk. the stuff had to work, and if it didn't work, they were just down the street. So you didn't have issues like inventory or even a lot of expense. And I did very well. I mean, at the time, because I was the only employee, and it was just basically me tinkering, and I had a great time. But I realized you couldn't really raise a family or have any, stability with that because it was just erratic. Mm-hmm. But then eventually we did actually get some production. One of the most interesting one was we made the world's first computerized embroidery machine.
Really?
There you go.
The biggest embroidery company in the world. Of course, there were probably 2 embroidery companies in the world. They made embroidery machines, and these were heavy, machines with motors and all that, and little old ladies would buy these, and these were operated with their knees. Very interesting.
Like a loom almost?
Yeah, they had, sort of. What it was is, you remember from day camp, you had a hoop.
Yeah.
And the fabric was stretched across the hoop. And when you weren't making ashtrays out of tile, you would use these things to embroider, embroider things.
Right, home sweet home, right?
That's exactly. And prayers and psalms and things like that. Mm-hmm. So we would take these little ladies would have. They'd have 2 knees. One would control the width of the stitch, because embroidery is different than sewing, because you're actually jumping side to side, making a thick trace. And then the speed was controlled by the other knee, because their hands had to be free to move the hoop. So they had a very, very clever, interesting guy who had taken over this company, which was started in like 1870 or something. And he decided, somewhere deep in his mind, he thought that this could be automated, because they were losing their business because these little ladies were dying off. So,
okay.
But
so this is non-industrial type.
Oh no, this was, what would happen is bowling shirts, sports, all the stuff, monogramming sleeves on shirts. It was a surprisingly big business.
Yeah.
And there were shops that had many machines, and there were people that just did it in their basement. So we used an F8 processor. This was good old Fairchild F8 processor, and we had
too young, Chris.
brilliant guy who from Keithley, and he slogged through this software, just ones and zeros with 100 feet of teletype tape, and we got this thing to work, and it was really advanced in its day. For example, we had a video camera to digitize logos. So you could put your logo, and then it would generate an audio tape. That was the storage.
That's the encoding of the data.
Yeah, to digitize the image, and stepping motors would move the hoop. And we would sell just the boards. And I still remember, we would sell the board set for $1,000. Well, of course, we had a year design. And they would sell the machine, I think, for $10,000 or something.
Wow!
And their business went from $1 million a year to $10 million a year in 1 year. They were the Inc. 500 fastest growing small business in the country.
Wow!
And we were just seventh heaven, and then the Japanese bought the company.
Right.
And that was it.
That was that.
Yep.
And that really...
No more Fairchild processors, right?
Yeah, that became the story of my life. The problem with being in the design and build business is you don't have control over your destiny. Mm-hmm. No customer ever would take the design. We would always just do the design for free, basically. Mm. And it was on a handshake. Everybody was very, loyal and fair, but just things... We had customers who would drop dead.
Really?
We had customers that would go bankrupt. Big customers. We get stuck with the inventory, and so it wasn't a fun business. And
could you clarify with the build side of it too? So you said you did design for free, but were you actually doing the higher volume as well?
Because the money, obviously, we did the design for free. The money had to be
true.
something.
Yeah.
And so a stuffing house would quote a job. Say it didn't take equipment. So they would say, okay, we're paying our people $10 an hour. We'll try to make $15 on every hour they work, and it's a tight margin business.
Yeah.
They and the parts they would maybe charge a couple percent on handling charge, depending on how long they would have to float the inventory. But it was a premium service, so our margins were a little better. Nothing like the margins on a proprietary product, but so I don't know. We probably did back then $3-4 million worth a year, in business, and some years.
That's a pretty decent sized business back then.
Yeah, that's right. That was real money then.
And
so,
how many people did you have at that stage?
Oh, it varied a lot. I know for quite a long time we had about 10 or 15 people, and then it probably got up to 50 or something like that.
Wow.
And so, that was an example of one of the products that worked well. But we did some electronic ballasts, and we made car wash controllers.
Really?
Yeah. So
That's
when
cool.
you drove up into the car wash, all those pumps would turn on and off.
Right.
And those things have hundreds of I/O lines.
Really?
You don't realize those unbelievably. They have built in all kinds of cash register auditing interfaces, and they know everything.
How did you find you were getting your jobs then? Was it word of mouth, or did you actively have to go out and sell yourself?
It's interesting from sort of a cash flow standpoint. If you're making a proprietary product, say you're making, voltmeters or instruments or power supplies or, whatever, something that has your name on it, you have to build these things. So you have to buy the inventory, you have to build them. So you're going to build 100 power supplies because that's an economical quantity. And then you put them on the shelf and you hope for people to come along and buy them. You have to have a lot of cash. You have to have a lot of very professional marketing. You have to know what you're doing to do a business like that. But if you're in the design and build, or for that matter, the stuffing business, you're a contract manufacturer, and there you don't do anything until you get the order. So you don't really have to carry the inventory. We could ship things before we had to pay for the inventory. So I never had any money. I started with absolutely nothing. And so in order to build up, if you don't have any money and you don't know how to market very well, a contract business is not so bad. The same thing might be true of a consulting business. But in terms of marketing, it really wasn't my thing from a personal standpoint. And on the other hand, you tended to do business locally, so you'd put an ad in the Yellow Pages. You just didn't have the communications you have now.
And it was a little better around
It was
then.
an entirely different world back then.
Yeah, absolutely.
A lot of young people don't know a world before the communications revolution.
Exactly.
To make an international phone call cost, $100 or something. It was
that's
bloody
right.
expensive.
And imagine importing something from China in those days. That was just
unheard
out of the
of,
question. You couldn't import something from Pennsylvania. So the marketing, I would have customers who would leave one company and go to another company, and that would be, in a sense, marketing.
Right.
So it varied a lot. There were ups and downs. There were a few consistent customers that, like the car wash went on for years and years. And that was actually pretty good. That was by far the largest car wash system in the country.
What do you think about the new... Well, it's all changed now because of crowdsource funding, where you can get the money up front for your widget. You don't have to fork out that $10,000 to build 100 units or whatever. That's
right. Now, people on the outside looking at that often have a misconception, and the misconception is that you're investing in the company. You're not. You're simply placing an order.
Yeah, exactly.
And you hope that the company will come through.
It is.
And, it's interesting because in mail order, or whatever you call it now, there are certain laws governing the fact that you have to be able to produce the product.
Right.
So I imagine, for example, Visa will inspect or study if you want to sell something and use a Visa card or credit card. They have an obligation to make sure that you really have this product. If it's not on the shelf, it has to really be there.
Yeah.
So I don't know how they work around this, but of course the scale of it isn't that large.
They might run into it eventually.
Yeah, but I think it's a terrific idea. I think it's very, very interesting. It hasn't settled into my brain yet exactly what is going to happen. If you have a few failures, that could burn people. Because remember, you're still depending on the strength and stability of the company to give you your money back.
Well, that's the
even
thing.
though it's only a deposit.
That's the big thing about this, is trying to sell to people in your video, usually, your pitch video about, you can trust me because,
I did this,
I did
right.
this, or I did this, or
That's right.
something
Yeah.
like that. So that's what you've got to sell, is your ability to actually produce the final
Right.
thing now.
And with the best intentions in the world, you might not be able to produce
exactly.
it.
A lot of things can happen when you when you haven't
I-
actually produced that item before.
Right, and it's not as if the money has gone into legal escrow. It's not as if the provider has any kind of credit rating or anything.
Oh, no.
So, but on the other hand, it's nickel dime. You're not
Right,
you're
yeah.
risking $50.
Most people are buying $100 versus
Yeah.
$2,000.
It's usually under
Nobody's
$100 or something like
Yeah,
that.
so nobody's going to go crazy. The bigger change, though, is the security. I know I don't sound like an engineer. The security laws have changed to make it easier to actually invest in small companies.
Mm-hmm.
And that hasn't hit the books yet. I think they're writing the regulation, but that's going to be very interesting. You're going to have all kinds of scams out
Oh,
there.
yeah.
Oh,
Snake,
yeah.
snake oil out the wazoo.
Yeah.
Oh,
boy.
yeah.
So
We're-
that's like
we're just
another
waiting for that one.
lever. Right.
Yeah.
That's like another layer on top of the the
We will have a
Kickstart.
resurgence of Shonky Product of the Week, and it will be strong.
That's right. Yeah.
Well, this is all in contrast too, because we always hear about like the Apples of the world that were leveraging different payment terms, right? And I'm not sure if you
Yeah.
ever had to deal with that as a design and build kind of house.
Well, with design and build, as I said, it's a little bit easier.
Okay.
You still have a bank, and don't get me started on banks, but let's just say that my firstborn was signed over
Oh.
Yeah, right.
along with my house and everything else.
Yeah.
And some people don't realize. I think it's colloquial, but realize what an entrepreneur is on the line for
Right.
in these
I
situations.
think, and more so back then as well. I mean,
Well, I'll tell you though, I feel sorry for anybody trying to start a business now because they're just not writing loans.
yeah, but now there's outside investment. I think you see a lot of like internet type startups. You have venture capital, and they don't really have as much vested, right? You lay down some part of you, or your.
That's right. That's
your-
right. The percent. Let's face it, though, the percentage you only read about the winners.
True.
Yeah,
The
of course.
percentage of people who are knocking on doors
Yeah.
and looking for money is the number of people, I should say, is unbelievable.
Yeah.
It just it's hard, and the reason is imagine how many business plans a known venture capital firm will get
Yeah.
in a week or a day. It's just you just can't read them.
Yeah.
And I think it comes down to who you know and things like
Oh
that.
yeah. Big time.
And the
So,
other,
It's really a choice when you're starting up your company now, and whatever it is you're trying to do, your startup or whatever is the buzzword.
Mm-hmm.
You've got a choice between leveraging your own funds, right, or taking on that personal risk, getting your own
Yes,
loan from the
yes.
bank, but you still
Yeah.
own everything, or risking someone else's money where if it fails, well, you're fine. You don't have to declare yourself bankrupt or anything like that. You've just lost some poor investor's money.
well,
So,
yes,
but then you
there's-
give away
there's
your
hooks
company,
and everything.
right? You're
Right,
effectively,
exactly.
in
Right.
exchange for that lack of risk, personal risk,
Yeah.
you sign away your company to someone else.
Right.
That's-
And I certainly don't mean in any way to to speak poorly of banks or venture capitalists. I mean, this is they certainly serve a purpose. There's no question about it. But from the entrepreneur side, you have to understand banks only loan money if they're guaranteed to be paid back.
Except for
to
the
do
global
other-
financial crisis.
Well, yeah, we're
Yeah,
talking
yeah.
about
a different ballgame.
commercial
We're talking about
banks.
real businesses here,
Yeah,
right?
we're talking about-
not derivatives.
Right. Let's talk about commercial banks doing
Yeah,
the
yeah.
kind of business they did up
Of
until
course.
that banking law was changed. And the idea is that, the people put money in the bank because it's safe, and the bank
Right.
is supposed to only lend you things where you can pay it back. So what are your choices? Well, you can collateralize your house, or your wife or whatever.
Oh, your firstborn, yeah.
And in a few cases, you can collateralize your inventory, and that's
Oh, yeah.
a stretch,
Yep.
or your accounts receivables. So, I had a terrific guy who, all along started out more or less on the manufacturing floor, who was pretty much self-taught, but he was a brilliant financial guy, it turns out, and, always managed to get through.
Was that a key to success? You think? I mean,
It's funny, but I would never write a check. I figured my time was more important designing or building or something than it was trying to keep the books and learn what Social Security tax will be.
Yeah.
So I always had, some little old lady, to come in and do the books or something like that. I mean, I really recommend that.
Yeah.
And you really have to, if you're the only one or in a small situation, you've got to look carefully at your time. You can't be running a drill press. You've got to turn that over to somebody else and do the high value stuff. So I didn't want to mess up. The last thing I needed was the IRS because I forgot to fill out a form. So I always was very careful to. And there's bookkeepers around. It's very reasonable. But so on the one hand, you could borrow money, and on the other hand, you could take an investor. But there's a lot of complexity to taking a venture investment, but the rule is very, very straightforward. The rule is that they will, and again, I'm not trying to speak disparagingly, this is the way it works. This is the game, because most of their deals, they lose a tremendous amount of money on. But what they do is they'll say, okay, let's look at your business plan, your projections, and all that. And I always tell people, Bill Gates never wrote a business plan. I mean, let's put an end to the business plan concept right now. But they'll look at your receivables, they'll look at your projections and all that, and they'll say, great, you say you're going to do $10 million next year, so we'll take 35% of the company, and we'll loan you, whatever you need we'll loan you $1 million, so you have enough money to buy parts.
And that makes you worth X, right? That's what they say.
Yeah, the valuation, but whatever it is, you don't care, you take it.
Right.
The problem is in the contract.
Yeah.
Right? The contract is written such that the VC will take control.
Yes.
All right. Just go with the flow. Don't think that they're not going to take control. And it's very simple. I'll give you a simple example. Your projection said you would do $10 million, in 2 years. Well, they write in a contract that says if you don't do $10 million, we get 52%.
Right.
We get 85%. And that's what happens. Yeah. And of course, you see what the negotiating is here. You try to make your projections look as rosy as possible. Maybe you stretch them a little bit. And it's a classic negotiating skill. Yep. The VC will say, fine, you said you're going to do it.
Yep, let's see it.
Yep.
And that's why the entrepreneur, on a good day, will retain, a small percentage of the company. I mean, this is the way it is. Friends and family, of course, that's different. But that has a whole host of other potential
awkward
problems.
Thanksgivings.
Yeah, very awkward things.
So let's get back to the actual your business.
Okay.
So you didn't actually take VC money though.
What happened was when we were doing the design and build, we poked along pretty well.
Okay.
You have good relationship with your customers. It's a very close relationship. They'll help you out. Just like we used to help out our customers all the time. We'd say, listen, we'll help you with the design. It's a good idea. Or some very grateful customers along the way because you work really hard to help your customers. However, as I said, it was just sort of, it goes back to the old make money while you sleep. You want to have, ideally, an organization that sits there churning out something while you're on the beach.
Yeah.
It doesn't work that way, but that's everybody's goal. So what you do is, what I decided was I really wanted a proprietary product.
Okay.
And did I pick a terrible proprietary product.
And yet you built your legacy on it, right?
Yeah, what happened was that I just, make a long story, met some people at the gas company, big gas company. And in the process, and I'm actually pretty proud of this part of it, because I started nosing around saying, well, I have a meter reader that comes to my house every day, and he goes down, he knocks on the door, he stands there in the rain, he knocks on the door, he kicks the dog, goes downstairs. Isn't there a better way to get the meter reading? So I spent, I think, 2 years learning the meter reading business.
Really?
They were very helpful, and I would look at, how many meter readers are in a hospital at any given time? And they were on disability because they'd fall down the steps.
Oh, really?
How many lawsuits you get because something is stolen, okay?
Right.
What is the turnover? Meter readers, the turnover was 100%. Can you imagine managing people that make minimum wage and turnover 100? And it was horrible.
Right, yeah.
And they were, at the time, they had IBM punch cards on a ring, and they were always getting wet and soaked. And so the meters would go to the bar, and since they had the previous readings, they would guess, and they'd write down the next reading. They'd sit in the bar all day. There's even a name for it. It's called curb reading, because they would sit on a curb in nice weather. So the meter reading business was a mess. They would get sometimes 60, 70% of the reads. The best story is they tried passing out these little plastic cards with little needle pointers on them. And you would rotate the pointers so it looked like your gas meter, and then you would hang it on your door. Great idea, except
Right.
the rivets, the eyelets were too loose. So every time you close the door, the dials would spin. That's a true story.
That's great.
So,
So you were building a value proposition.
that's
basically.
right.
Yeah.
And
So,
I
so was that
really-
based on the honesty system? The person
those
would
cards?
Yeah.
Well, there's all kinds of rules. For example, no matter what they do, reading the meter, guessing, curve reading, they have to read it once a year.
Right.
But here's a fascinating aspect of this. Your gas meter, okay, is calibrated. It's a positive displacement meter. And the utility commissions have very elaborate controls over the calibration because no meter is perfect. Some are plus, some are minus. But you have to prove that over the aggregate, the average calibration is always in the customer's favor.
Really?
Isn't that
Oh,
interesting?
right.
Oh, that was a fascinating
Yeah.
tidbit of information because they couldn't guarantee that they were going to be perfect,
Right.
and they would sort of say, "Well, gee, we want to,
Yeah.
So everybody.
So-
So the decision was that they sample these meters. They would go out and get 1,000 meters a year, bring them in this, very, very accurate positive displacement calibration
Right.
scheme. Big brass.
Spared no
pipes and
expense.
stuff.
Right.
Yeah, and they could calibrate to 1/10% or something.
Wow.
Temperature compensated.
Wow.
They were made out of leather. They had
Really?
these leather bellows inside. These things would last for 50 years in the field. But they would always make sure that on testing, they would always favor the customer. If they didn't, then they had to go out and remove all those meters of a certain date code or
So
something.
the house always wins, but in this
The house
case, it's
slightly.
your house.
Yes,
It's your house.
Right. The house does win.
Yeah.
So, but that's just an interesting sidelight. But anyways, the meter reading was a real problem. And there was a history of gadgets and stuff like that. One of them failed notably because there was a little hole in there, a weep hole, to let the water out of this gadget on the side of the house. And there was a certain spider that would go inside this thing and clog up these little gears and stuff. So anyways, so nobody really had a solution. So the idea was that if we could move the inside, the reading on the meter, which was in the basement, gas meter or water meter, to the outside,
Yeah.
and then build a computerized thing that the meter reader could access, and get the data, then we'd have the problem solved.
Yeah.
We
So-
have an easy solution for this here in Australia, by the way. We just mandate that all meters are built on the outside of the building.
Yes. There are historical reasons, though, and
Of
you're
course.
right. And in the U.S., most meters are outside, but still,
Right.
I know 30% of them are. Well, the biggest problem is water tends to freeze.
Yeah, especially in
Right.
Cleveland, right?
Yeah, and most
Right,
of the country.
okay.
I mean, it only has to freeze once.
All right,
So
fair
the
enough.
meters are in pits or they are in basement. Pits are terrible to read too.
Yeah.
You have to pump them out. And so, anyways, but gas meters, gas used to be called coal gas, and so gas meters there's a lot of moisture in there because it was a steam process, and so gas meters would freeze and they had to be inside too. So, anyways, in a lot of the country, that's the case, and so it was very expensive to move them outside. So the idea was we wanted to remote the reading and have a sort of a non-contact little data link. And so we basically had a little computer that we would stick to the meter, and we had various means of sensing the dial going around, like the 1 gallon or the 1 foot per minute. And there would be a register, and a lithium battery, and AA battery. And then the outside of the house, we had would amount to half of a transformer. And the meter reader would come along with a portable computer, essentially, what now we would call a smartphone. But this was a dedicated
Right.
device.
Yep.
And point it at this thing, and they would talk back and forth. It would wake up the thing in the house, and it would send back the meter reading and the ID number. And it was a great little system. We knew that there were a lot of handheld computers out there already. The business had just started. This was in the early 80s, mid-80s. Some of them used paper tape and mag tape, and they were terrible. But they had like 16K of memory or something.
Yeah.
But so we didn't get into that business in a big way, but we just made the thing. Again, I wanted the production. I didn't want to have a lot of expensive programming or software support. There are a lot of legacy systems,
Right.
IBM 360s and
Right.
utility and all that. So the meter reader would walk around with his handheld device, get the meter readings, and then go back to the main office, and he would download them into their computer and their billing system and all that.
Yeah.
And we sold about 2 million of those. We even sold some in
good.
Mexico. Yeah, but then probably 5 years into that, interesting thing is those were installed starting about 86, 87, and some of them are still out there. That's 25 years on a lithium battery. That's pretty good.
And this is Hexagram, right? We didn't say the name of it.
Yes, the company at that time, as it was founded, was called Hexagram.
Where did the name come from?
The name came from a Leonard Cohen folk song.
Really?
Oh,
and I had no idea what a hexagram was. It just sounded neat.
Yeah.
And the line was, I put my hand upon the hexagram and then upon the girl. And only Leonard Cohen knows what that means. So, but it's actually a Amish anti-hex symbol. And a lot of Amish people around here, so there's a couple names for it. That was just neat.
That's fun.
Pentagon wouldn't have worked.
No, probably not.
Right.
Hexagon was a soldering iron company. So.
Yeah.
But anyway, so that device was successful. We were still doing the subcontracting.
So for other clients?
Yes, we're still doing the design and build. Yeah,
Any conflict of interest?
No, not at all.
Okay.
Because our companies were utilities. The reason I said it was a bad choice of a proprietary business was there were many aspects of it. But among the biggest was the time to sell, the time to sale.
Yeah.
We had one utility in Kansas that tested it for 8 years. I mean, talk about cash flow.
Yeah, right.
I mean, you're paying a salesman, and,
Can't eat IOUs, can you?
gosh, or expectations.
Yeah, right.
Yeah. But in any event, the problem was that the technology passed us by. It's not like we had a lot of, assets. Oh, by the way, another story is that we had a full custom IC. Remember, there were really no processors then, and there were certainly no micropower CMOS processors. So we went to National Semiconductor, and they thought, oh, this is neat, and we were going to make a full custom, they were going to make for us a full custom silicon part. And I think it was $100,000, or something like that.
Yeah.
And it was a 200-gate equivalent.
200 gates.
Yeah,
You should have done it.
There was a breadboard someplace.
Yeah.
But anyways, we obviously couldn't fit 200 gates on a little box the size of a matchbox, so we had to go with an IC for cost reasons. Yeah. And they were a year late in delivering it.
Ouch.
And it was a nightmare. I mean,
that's why they're not around anymore, right?
That's right. Well, here we had, we had paid half down. We had an order, I still remember, for 330,000 of these things.
Really?
And we were just sitting on the order.
Oh,
and we had injection molded parts, and powdered metal parts, and all this stuff, all the machinery, and we just had to. Then we had a venture investment.
Yeah.
And
you didn't have to eat that whole cost, did you? Like, did you lose the order?
No. The utility stuck by us. They were great. They really
awesome.
did a great job. Yeah. So, and they were desperate, and there was nothing else.
Right.
That helps.
Yeah. But I mean, the cost justification was pretty easy. So anyways, that's when we took a venture investment. But as soon as we started shipping, we bought it right back out.
Really?
So we didn't have a flip. I retained control. We got rid of them. They weren't very. They were benign, I guess is the word.
How did you get rid of them? How did you get? Did you just pay them out?
We paid them out. Yeah,
right.
There was a preset buyout.
So there was some figure that they wanted return on their investment, and they were happy to take it.
That's right, because they were only in for a couple of years, and they probably made several $100,000. I found out later that there was a bet that would always happen when we had board meetings, and that was who was going to fall asleep first in our board meetings, me or the representative of the venture firm. So I heard that years later, because there wasn't much to talk about. Everything goes well, everybody's happy.
That's good.
Yeah, you make your numbers.
Success is boring, huh?
Yeah, right. So that was the first crisis, but then I realized we had to evolve. And what happened was, in our system, we put the microcomputer on the gas meter, and then we ran a wire out to this little ferrite.
Yeah, it's like a nub,
air
right?
core, right?
Yeah.
There's an air core coil on the side of the house.
Yeah.
And there was resistance against running that wire.
Really?
Yeah, because it real or not, that was the problem with our system. When there was nothing else, it was no problem. But then they came out with an RF device, an RF competing product. Actually, a couple companies did. And the way this worked was that, again, assuming you had an indoor meter, although this was supposedly justifiable for outdoor meters, they put a little passive receiver on the meter and a little, what used to be called a Part 15 transmitter, unlicensed transmitter. And the idea was that a truck would go by with a, 250-watt thing that they would blast these things. They'd wake up and then transmit the meter readings back with an ID number and stuff. And they would do things like randomly time division them and things like that. And it sort of worked. There were a couple out there. It never worked as well as it was supposed to because just when you look into the current drain of the passive receiver and all this kind of stuff, they only had microwatts of power. Yeah. They could only go about 100 feet. Well, there are all kinds of problems.
So was this like current day passive RFID kind of stuff where it actually uses the received power?
Yeah, but remember, the truck could be 100 feet away.
Right. Okay. Right. And power law.
Yeah, right. So, there were all kinds of issues. It worked about 85% of the time. They would drive down the street and go 85, because they never published that
around,
figure.
Right?
And it would come back, or they would stop the truck and the guy would get out.
Oh.
As it turns out, the most frequent implementation, they just skipped the truck. And they would just have meter readers, just like they always had, with a handheld transmitter, and he'd wave it around.
Yeah.
Yep.
And so the problem was this always required the meter reader to go to the house. It was still on-site meter reading. But their system cost twice as much as ours. Theirs was maybe $50 and ours was $25. And that was enough of a differential that it wasn't enough differential to overcome the problem of running the wire. And I knew this.
Right.
I knew this as soon as these things came out. So then it was a problem because we were winding down probably in 1994 of the sales of our remote reading device, and then I had a real decision because we had a fairly big company by then. We probably had 40, 50 people. And I didn't know what to do. So I figured, well, this is the business I know. I've been going to trade shows. People know the name. They didn't buy it, but
yeah, exactly.
Details.
Well, who's going to buy from this little tiny company? These utilities, you could sell them a system that would handle $100 million of billing in a year, their entire revenue stream.
Yeah.
Who's going to buy from some junky little company that might not be there? So we had some good relationships with a couple of utilities, but it just wasn't going to fly long term. So I decided, well, we'll just bet the farm, and we'll come up with the world's greatest meter reading system, the one that is the holy grail, which would be that you sit in your office and the utility gets all the readings, magically. You would not have to visit the house at all, and you could read it every day or every hour, whatever you wanted. There had been efforts at this. Famously, Motorola and Schlumberger started a joint effort. This was funded initially with $10 million, and these are big, powerful people. Motorola, because the radio
companies,
side, Motorola had the radio side, and Schlumberger owned a big company that made gas meters and some other stuff in the business. Yeah. So we'd heard about this, and they were plugging away, but for some reason I decided it might be, it's either be fun to try or the only game in town, because you had to come up with something new.
I enjoyed how nonchalant it was. Well, I guess we'll just bet the farm, whatever.
To this day, I get a cold sweat just thinking about it. What made
hell
me
was I thinking?
Yeah, and so, but there were a couple of interesting things happens. First of all, one company that tried it did it wrong. They made two major mistakes. And they've been bankrupt. I think they might still exist in some form. They went bankrupt a couple of times. One is that they used an unlicensed transmitter, just like this other device I mentioned. So, of course, the range was terrible. And they were always struggling to try to get the range out of it.
And that's governed by actual power,
by the FCC, right, and the laws of physics. So it was a struggle. The other mistake they made was very interesting. So you would install data collectors, or whatever you want to call them, receivers and computers, on some kind of a matrix to pick up these transmissions from the individual homes. But then you had to collect the data. So what these guys did was spend, I don't know how many millions of dollars for a proprietary microwave link to connect.
Each house?
No, not each house, but each data collector.
Yeah.
Oh, okay.
So, say they went, I don't know, a quarter mile or something like that, you would need every square mile, you need 4 of these things.
Oh, God.
There's a lot of data rushing around there.
And they'll probably rubbing their hands together. Oh, we're going to sell 100,000 of these $1 million bloody base stations,
That's right, but I think it was more engineers gone mad because
Right.
Look at these problems we could solve.
Yeah.
we did it with a cell phone on nights and weekends.
Yep.
So we got analog cell phones. They were free if you got a 2-year contract, just like now.
Right.
We would throw the bag away, throw the handset away. We paid nights and weekends, $10 or something. Great for sending data back. And it would make a 1 or 2 hour phone call. And it would, be able to send all the data
Like
back.
modem style?
Just a bag phone. We used to call it a bag phone, yeah.
Bag phone, huh?
But so, anyways, that company made those mistakes. The other interesting thing is that this company that made the drive-around systems kept promising that they could migrate to a fixed network. They said, "Well, we'll just put a data collector." No, didn't these people ever take algebra? The thing transmitted 100 feet. So that means you have a data collector every 100 feet. Well, your next door neighbor is about 100 feet away.
Yeah.
And sure enough, in their test, they would have a $1,500 data collector for every meter.
Ouch.
And they kept trying to sell this thing. Well, there were stockholder suits and all kinds of ramifications. And it obviously failed.
Yeah.
So we would go to the trade shows and we would try to point this out, and nobody ever listened. They would actually laugh at the other company and some of these other efforts, but they never believed us.
Yeah.
So it was tough. But then the other thing that happened was, and there's a lesson here someplace, the FCC in 1996 changed the regulations. And I'll briefly mention it because we supposedly have a technical audience, and I don't remember the details. What they said was you had to have a certain bandwidth utilization factor. In other words, you couldn't make a transmitter that could have a narrow bandwidth. In other words, you had to have the transmitter had to have the capability of sending lots of data. Okay, I forget what the number was.
So no Morse code
That seems rather silly, doesn't it?
Well, it wasn't.
It's not encouraging frugal use of bandwidth.
No, it is. Because you'll need less users.
Oh, okay.
Instead of having to take 10 channels to send something.
Right. Okay. Yeah.
Right. So what they said was that every transmitter had to have, and again I apologize, but you had I think a 12.5 kilohertz bandwidth, and you had to send, I don't know, say 6 kilobits, per second or something like that.
Yeah.
Well, it wasn't easy.
Really?
Well, the people that did it, good example would be a police radio. So with a $300 radio, okay, they would have a powerful output amplifier and then a very expensive filter to shape it so they're not outside the spectrum.
Right.
Well, we're trying to do this for $10.
Ah, right.
And it wasn't easy.
Right.
So we're thinking, and no matter what happened was, though, that we were never able to get this bandwidth requirement. So Motorola and Schlumberger shut down that operation. They said, well, they changed the regs. We're not going to do it.
Oh, okay.
All right.
But here's where they went wrong. They didn't read. They always say that when you take a test, read the question.
Yeah.
There was a loophole.
Technical loophole.
Because the FCC said you had to have such and such a spectral efficiency or equivalent. And nobody saw the or equivalent.
Right.
So what they said was, what I argued was, say you give somebody a channel, a licensed channel. They're free, So you get a licensed channel, you get them forever. And you're a flower shop. The flower shop has 2 trucks. And they'll do $200,000 of your business. So talking to 2 trucks, they'll use up 1 channel.
Yeah.
Okay? We can't, we're having the spectral efficiency limitation because our transmitter isn't as expensive as fancies are. However, we're going to have, in the same service area, maybe 100,000 transmitters. And in the aggregate, the spectral efficiency is unbelievable. We're going to be taking one channel, and we're going to be using it for millions and millions of dollars of revenue, tens of thousands, hundreds of thousands of users.
Yeah.
And because we only transmit, in little bursts.
Right.
And they bought the argument.
Nice.
Right.
And so everybody else went home, and we were sitting there turning this thing out. And, I mean, there were some eyebrows because, you have to submit all the information, and there were some arguments against it, but the FCC loved us because we're using bandwidth just the way, for a very important social good.
Yeah.
And that's exactly what it's supposed to do.
That's great.
So we read the regs, and I wrote this letter, and I had an attorney help, an FCC attorney help with it. But they allowed us to proceed, issued the channels, and issued the certification of the product and everything.
So what year is it? What year is this now?
This was about 1996.
Oh, that's right, when the regulation changed.
Actually, we started testing in 95, and then we changed the product a little bit to meet the requirements.
Right.
So we could send then a very low a bit rate. The meter reading is about 1 bit an hour.
Really?
And
Wow.
that's all it is. I mean, because you want to read a meter once a month, there's not much happening. But there's a little bit of overhead, of course. But the idea is that if you send a very, very low data rate, you can have essentially a very sensitive receiver. Because you can do lots of processing. You're not trying to send high bandwidth.
Right.
So we could keep the costs down. Very simple FM modulation. Nothing fancy. And we didn't have to waste power in our to meet the emissions mask. We didn't have to use up a lot of power.
Right.
Still a very difficult product to design. But when all is said and done, it was inexpensive.
Wow.
So that's what we did, and then it was a great product, and then nobody bought it.
Oh.
So,
Oh, right. I thought you made a killing on this thing.
it took a long time.
Oh,
because,
right.
Again,
Okay, but it eventually did pay back?
utilities- Yeah.
Right.
What happened was, that, we sold a couple of little tiny utilities who were so desperate because their meter readers were in jail and stuff. And then we eventually sold a couple of utilities that were very well known in the field. And eventually it did fine. But again, we had to take another venture investment, which we probably didn't need, but the lag between developing the product.
Well, that in
and
hindsight,
selling,
right?
Oh, yeah.
Yeah.
So what are you going to do?
Yeah.
And not
But,
long after that, you were acquired.
Yeah, in 2006. And there was from a company, what happened was, don't ask me how this happened, another cold sweat. There was a very, very large order, I don't know, $250 million order out there.
Wow.
That everybody was waiting for. It was in California for the big utility, and lo and behold, we got the order. I was actually absolutely stunned. And thrilled. I mean, it was exciting. Another company, this was for the gas meters, another company had the order for the electric meters, and they were large, publicly held, and it was, we figured that arrangement would work. So, it was, pretty much able, I think, to protect the jobs and things like that. So, I decided it was time to, do something else. So.
Oh, yeah, that's great. And so you're saying that the large order actually kind of brought the attention,
Yes,
and then that actually led to the acquisition later.
Now, I think that the successor company, which is called Aclara, I think they've made now, starting back in the 90s, I think about 10 million units, if I believe.
Wow, that's great.
Yeah.
And so now, if people see these actually look like large metal boxes up on...
No. What you have is a little plastic box.
Oh, sorry. I was thinking about the...
Right, a little plastic box on the side of the building or in the basement. The data collector you'll never see because it's up on a roof. Typically, it's on schools.
Oh,
because schools are distributed at roughly...
centralized.
Roughly, in every area will have X number of schools per square
or maybe
area.
libraries or something like that.
Yep.
And this little guy will transmit, I think we tested it out to 25 miles. I think the calculated transmission distance is about 75 miles.
And how many houses could you collect with one
it's
data point?
It's essentially unlimited. The trick is is diversity. In other words, we have antenna diversity because we have multiple receivers. Mm-hmm. So one device, say in a downtown, real busy area, maybe it'll transmit a mile in one direction and a quarter of a mile in the other direction. So a couple of units will pick it up. I think we designed for typically about 3, or maybe a minimum of 3 would pick it up. But sometimes you get 5 or 10. Sometimes you pick up in the next town.
Right.
You've got to understand the statistical nature of propagation of the channel. It's just amazing. Again, you can go from a mile to 75 miles is typical,
right.
and
it can change daily too, based on the weather and all sorts of.
Yeah, now we're at a relatively low frequency, so
okay.
Which most people try to go for high frequency. They had no idea what they were doing because we didn't have to have a small antenna. So why in the world would you have high frequency? Why would you want a high frequency?
Yeah.
Right.
We could have an antenna that's big as a cigar box or something, and nobody cared. I mean, it's just engineers bite on something, and it's just like a dog; they won't let it go.
Yep.
And, hey, take a step back. Cheaper semiconductors, easier to get gain, lower power consumption.
Yeah.
Everything screams lower frequencies.
Yeah.
Even now I notice that a lot of the action in auctions for spectrum is they want the lower frequencies, the 800 megahertz and 700 megahertz left over from the TV as opposed to the 900, because the propagation is so much better.
Right. We had a guest on talking about microwave, and he was telling us about the long distance of like microwave transmission is very difficult.
Yeah, and you have more problems, with multipath and bouncing and all that.
Yeah.
But it's really amazing. If we designed that we had to go a mile, we expected to go a mile, you really did have to have an open field range of about 25 miles.
Interesting.
You really did. I mean, that's the number. That's the way it works.
Wow.
Anyways, but what's interesting is the statistical aspect of this, because if I have this one transmitter and I've got a large matrix, a large grid of data collectors, maybe I'll hit, say, 3 of them.
Yeah.
Some days I'll hit 4, some days I'll hit 5. But also, I transmit, say, 4 times a day. Okay? And I don't need to get a reception every day. I might only need it every other day because meter reading just is like, who cares?
Yeah.
So you get a bill once a month, and there's some tricks there. So anyways, what that means is that I have all this diversity. I really have, 5 or 10 or 15 tries.
Yeah.
And it's the sum of the probabilities. So we designed for one transmission having a 50% probability of getting through.
Okay.
Where else do you have the luxury of designing something that works half the time? But if you take 1 over 0.5 times 1 over 1, do that 5 or 10 times, we get out there 99 point, and we did. Yeah. We would get that thing 99.99% of the time.
And that's how you sell something.
Yeah, and that would include product that wasn't working and product that was stolen. And it was really a tremendous performance. Unbelievable.
Go math. Go your company. That's great.
But diversity is a good example. Like if you're going up your driveway, you stop your car, you press your garage door opener, nothing happens. But press it while you're moving. Yeah. You'll probably get it to open. That's the key. That happens to be geographic or antenna diversity, but time diversity is the same way. And of course, we do some error correction on it. But it's very interesting the way it works out. And I would say that what made it work was just I was never a ham operator or anything, but just had a feel for playing with the garage door opener, playing with a CV or something. Moving things around. You're always better off.
Yeah.
Now, so you sold your company in 2006,
right?
And you did pretty well financially from that, I'm guessing. And so you moved on to something entirely different.
Yeah,
tell us about it. This is interesting.
I went back to exactly the same location I was in 1970, the same building space where I was lecturing at the time, and I was able to help with setting up a new undergraduate design lab at Case Western Reserve, and ancillary space, electronic stores, and a lounge space and lecture hall, and things like that. And
was this during your time, Chris? Sorry, was this during your time there, Chris? Because Chris went to Case Western as well.
Mm-hmm. Yeah, this was actually my last year, and
right, okay.
My great loss of Case is that I didn't get to take Larry's class, although some of my fellow students said that I missed a little bit of misery, and I think I missed a lot more learning.
We call that challenge.
That's right, challenge.
Challenge, right.
And I'm sure Larry will tell us all about this course that he started up, which is Spectacular.
So, but anyway, so this is a really nice environment, and we have a lab director with a lot of industrial experience who helps prepare labs for professors and things like that, and a technician who's a great guy, again, with a lot of industrial experience. And so they're really mentors. They're there all the time. And it's nice that you're not, stuck in the lab without anybody to turn to. And, of course, we have TAs floating around and things like that. The other thing we have is access. We have a great flea market where all kinds of stuff magically appears, most of it from my basement. And, you always see people rummaging through the stuff, and frankly, that's how you learn.
Yep.
Absolutely.
Nobody teaches you interconnection, or why you use lock washers, but you see this by taking things apart. And we also have, more formally, you can make boards or buy parts or anything you want. All the stuff is complimentary, just because we're trying to get students to make things. And we see some really, really neat stuff coming out of there, and it makes me feel real good. So it's
just
facility.
One big floor on the building where everyone just hangs out, all the nerds just hang out?
Well, it takes a village, as they say. In other words, the chairman, the departmental office is there, and support people are all there, a couple of conference areas, and the lab. And the idea is that the labs shouldn't be, like we were talking about light, labs shouldn't be tucked away in basements. This is a real busy place. It's on the main floor of the building.
It's all glass.
The professors are always walking around, and so you see people, the head of departments wandering around. The campus tours come through. The lab is all glass walled. So it's worked out very well. It's become sort of a prototype, in fact, for other departments. In other words, labs are neat things to see. You shouldn't tuck them away. You should,
right.
People are there a lot. Something
Exactly,
to see.
yeah.
Right.
So how did you build
coffee
this?
Machine and
Yeah. Did you go in there with the idea to build this, and did you have to sell it to them? Did you, donate money to help build the first thing, or how did that work?
Well, I suppose somewhat facetiously, if you're going to pay for it, it has a tendency to get done. But
you should be a venture capitalist.
Yeah, that's right. But, over the years, I had seen this sort of prime educational space be taken over by other things. There was an NASA office there. Well, that's great, but that has nothing to do with students, Yeah.
Sorry.
NASA.
NASA.
Oh, right,
space
as in
people.
NASA, right. Yeah,
Yeah,
right.
that shouldn't have been there. And, certain back office functions, development, things like that. And the lab got smaller.
You get crowded out, right?
Yeah, the lab got smaller and smaller. Right. So this is an endowed facility. So the lab personnel, it's endowed, so they can't leave, and there's certain requirements, because I think this is pretty fundamental to education. Yeah, well, the politics change.
Yeah, definitely.
I remember when various technologies of note would come along. Everybody remember fluidic logic.
No.
You better remember that.
No.
Fluidic logic was the big thing. So
is this kind of like fuzzy? Is this like fuzzy logic?
No, this was pneumatic logic. Might
really?
be the word, yes.
Wow.
Where you would have little oscillators and gates and flip flops that worked with air pressure.
Oh, right. Okay. Yeah, I've heard something like that.
Yeah, I suppose it was great for radiation hardening requirements, but that's about the only one that comes to mind.
Exactly. Trains, maybe?
Yeah, trains. It's pretty hard to minimize. Although pilot valves are still around. That's a good example.
Yeah.
Right.
So, you'd have organizations starting to work on things like this, and then they fall out of favor. Lasers are another example.
Yeah.
Plasma physics was really, really large at Case, and it just, unfortunately, it wasn't a good choice.
Why? Why was that?
Because it died.
Yeah,
solid-state lasers took over, unless you're going to,
Oh, okay, right.
blow up things or cut metal,
Yeah.
So anyways, I just wanted to make sure that the undergraduate portion of this was stable and sort of appreciated and was going to remain there.
And replicating your making experience, basically.
Right, exactly. And, like I always tell people, is that you have people that make things say they're in junior high or high school, they have a workshop, right? Or they have a garage, or they have a corner or something. So they go to college, and the first thing we do is take away their tools. And, it's not a good thing. That doesn't really help. And so we try at Case to give them back their tools. And that leads into this other project, which I've been involved in, which we call ThinkBox.
And we've actually mentioned on the show before.
Yes, you did mention that, right. And this is what we are pretty sure will be sort of the country's most well-equipped fab lab, makerspace, around. It's very, very well funded, and we're just in the process of expanding it and buying equipment
Where's
as
the
fast as
funding
we
coming
can.
from?
There are a lot of people who are very interested in this, just alumni and things. No foundations or anything like that. It's typical,
Right.
and
It's
no
all
government money.
individuals,
It's
who are just
right.
passionate about this.
Right, and it's
Right.
about a $25 million program,
Wow.
and that's a lot of
That
machines.
buys you a lot of
Yeah,
toys.
a lot of laser
Right,
Yep.
a lot of laser cutters. We have more on order.
Yeah.
And we also have a 50,000 square foot building that the architects are working on, and we haven't broken ground yet, but hopefully that will be before too long. And that's going to be entirely dedicated not only to the sort of the fab portion of it, but we're envisioning all kinds of ancillary stuff. For example, just a big room where you can have contests and poster displays and things like that. Also, a sort of a business incubator side of it, where we hope we can encourage interaction with industry and
Possibly
just
even
helping
fund
people
some
start companies. Right, exactly. But there's a lot
microfunding
of
or something?
Yeah, there's a lot of launch type facilities around, but typically they're just in an office building someplace. We want to go after the people that have real hardware requirements, and we have a foundry. I mean, we got some. You're gonna have some neat stuff. And so instead of instead of a small company scrambling all the time, because they need a microscope or a sewing machine or a laser cutter or something like that, we want to have all that stuff available. But both to some local industry and certainly to our students.
I've been telling people that it's kind of like a tech shop, but on a campus, like
exactly.
a commercial venture where it's very high end. It's very
Right. Tech Shop and some other organizations are sort of open to the public in a sense.
Yeah.
This has a strong educational component, but certainly the people that have ideas and come out of it, we want to try to support them with access to funding, access to mentors, that type of thing.
Is there any vision to potentially turn this into a business that actually self-funds itself, or heaven forbid makes a profit?
Well, you're treading on controversial ground.
No, I'm sure I am. That's why I asked it.
Yeah, no, it's very interesting. There are two schools of thought. Most of these organizations do take a piece of the action.
Right.
So they say, you can use our facility and we want 10% or 15% or something like that.
Of what? Your business?
Equity in this startup venture.
Right, okay.
There's another school of thought, which is actually supported by some pretty powerful information, that says that it's not worth it. You're better off being sort of helpful and supportive and just depend on successful people to come back and help you out.
Right. Okay.
I suppose,
and there's some studies on
that.
that, or there's some anecdotal evidence to
Yeah, he's sitting in front of me.
say that's better.
Well,
Right,
I'd be
well,
an
okay,
example. Sure,
okay,
right.
granted.
I mean, just help people all you can. And the reason this project is to be funded like this is because, again, we want to endow everything so that we don't have to really make money.
Right.
I mean, we've actually looked at the operating costs of running this big facility, and it's really not too bad.
Oh, really?
It shouldn't be too bad. It's just the way the university covers some overhead and contributions and things like that.
So this is kind of like a version of sit on the beach and make money, but it's the reverse, right? You sit on a beach
and help other people.
Yeah,
Right.
exactly. Yeah, you just you have money, run the place, right?
Well, but for example, there are some revenue producing aspects of this. For example, we've had interest in companies that want to have a skunk works there.
Nice.
Because they have access to the equipment, they have access to faculty for
creative
consulting.
people, right?
Right. And how do these people get a name for themselves so that they can hire students?
Yes.
It's pretty hard. I mean, you have some pretty big but pretty obscure companies around, that are in niches.
Yeah.
Well, this way they can have their name on the door, they can have interns, they can have summer help, work on projects there and go back and forth.
Yeah.
So we're pretty excited
Joint
about
ventures with master's projects.
And we're looking at some other thing. We've actually considered apartments
Really?
It's a pretty wild idea, yeah. We don't know if that's going to fly, but
man, I've talked to someone about that before.
We're looking at it
having
seriously.
like a joint maker space and living.
It's the loft idea.
Yeah, loft idea, right?
Yeah, but also it's the entrepreneur in residence. It's temporary, visiting faculty, something like that, because it's right on the campus.
Oh yeah.
A lot of
where I used
these,
to live.
right? A lot of these these various campus innovation centers are not on campus. I mean, typically they're an old Kmart that they
Right.
converted,
Yeah.
but it's 100 feet from my office. Yeah. So so we're very excited about it, and
that's what you
great.
spend
A lot
all
of
your
aspects of
time
it.
working on these days.
no, I still have my basement.
Well,
right.
Yeah. You have to, right? It's like a compulsion these days.
Oh, it is. Yeah,
all
right.
days.
Yeah.
So,
right.
real quick, can you tell us about your class a little bit more? Just the
course I teach?
Yeah, the course you teach, and also maybe you said there's a new one as well.
Yeah, there's a new one. This is a big development. This is a freshman engineering course. It's called SAGES, and there are a very large number of courses that case undergraduates can take. I mean, it's a tremendous. I don't even know how many there are. I mean, it's hundreds or something. I don't know how many, but these are very small classes. Usually 15 or something like that, and they have to take something. But they're in, like crime in 18th century England or something like that.
Yeah,
all these bizarre things.
Right.
Yeah.
But which one did you take?
I was there before Sages started.
Oh, okay, didn't quite start.
Yeah,
Okay.
I skipped
But
a lot of
anyways,
stuff.
for the first time, SAGES is run by the Arts and Sciences Department, so for the first time we can offer engineering courses.
Yes.
So mine is volts, amps, bits, and bytes. And I have a med student, an astronomer, a couple chemistry majors, but we're doing what we can. We'll convert them all to become electrical engineers.
Yes.
But don't tell them
Excellent.
I said that. But no, I'm thrilled by the fact that we do have that kind of diverse people, because they're the ones that are, they must be excited about it to take that course.
Yeah.
And so it should be a lot of fun. And
See, that's not something we have here in Australia much in our university/college system, where you guys seem to take these bizarre classes that are totally unrelated to the degree you're studying.
it's called a liberal education.
Yeah, the
right.
well-roundedness is very highly valued for one reason or another. And
Okay, yeah, we just don't have as much of an emphasis on that here.
I tend to think it's a pretty neat idea. I think that a strong engineer is so self-driven, and that, of course, is the caricature, that you got to get them, out of the lab once in a while.
But do they have to? But what's the benefit in them learning, 18th century history, or something like that?
Because that's the only way to meet girls.
Yeah, right.
That's the way I decided what classes. No,
Yeah.
but seriously,
it's a real question.
This is a real deep philosophical argument.
it's the basis of education.
And of course, who said, what good is a newborn babe? So it's one of those stories. It has no answer. But anyways. So my course, and actually a number of professors are teaching sort of similar courses, but we'll do some neat things. For example, you're almost required to go on field trips.
Really?
So we're going to go to this, 250,000 square foot surplus place, which you've been to, HGR, and this is a phenomenal, just piled up with junk.
Yeah,
nice.
But you learn. I mean, it just, this is sort of like American industry before your eyes, and you look at a machine that dries plastic pellets, well, you can explain that you need an auger to move plastic pellets, I mean, how are you going to teach that otherwise?
Right.
So I'm excited about that, and we're going to visit a submarine, and just all kinds of neat things.
That's awesome.
A lot of movies related to engineering, so...
you should point him towards the EV blog too.
Pardon?
Dave's.
Oh, don't worry.
My
yes.
EV blog,
I
yes.
think I'll embarrass myself, but I'll tell them about this one. But, so it should be a lot of fun. And it's a seminar, which basically means that the professor doesn't have to prepare. But I'm still busy at it.
Yeah. So. No, that's great. No, I've always been, with especially with like the finding classes that teach analog, like your 372, I think it was 371.
Yeah.
I was always trying to recruit kids out of that because people that can actually bias a transistor.
When you were hiring.
When I was hiring, I stay on, and trying to bias a transistor, right? Surprisingly small, even like working with BJTs versus FETs. That is something that you wouldn't expect it, but I went and recruited at MIT, and you would be surprised how many kids at MIT didn't understand what a BJT was. And it's not any of these kids' faults, right? I mean,
no.
It's just
all
it's just a
courses
function
are
of
different,
the education.
Yeah. Well, I've always felt that somebody should make a list of the things you have to know if you're going to be, say, specifically an electrical engineer. I mean, you got to know what a relay is, you got to know what a BJT, you got to know what SCR is. Think about it. Nobody teaches SCRs or relays.
Right.
I mean, just to pick an example.
Right, exactly. Why would they when you
how does a lamp dimmer work?
Yeah.
Well, you don't teach these things,
Yeah.
you know? So, I try.
Yeah. Well, another question I had about that, too, is, you know, how a lot of our listeners are hobbyists and stuff. How many of the kids coming into these classes are hobbyists, or how many are just kind of seeing even, you know, just BJTs for the first time or something? Not, I guess, educationally seeing them, but
for years I've hunted a correlation. I asked the question, do you own a soldering iron?
that's a good one.
Right. Excellent.
I think the correlation is there. It's not as high as you might think. Generally speaking, I think these kids are fabulous. I really do. I think some of them are just unbelievable, and very few, you know, are lost. I didn't know what the caliber of the kids would be like, but I'm really impressed. I think they do real. Of course, I only see a little tiny section.
The ones
20
that
kids
decide
that
to
take
jump
my
in,
course,
yeah.
and they're obviously, and the course has a reputation, and so you got to be really interested in it to take it.
I was
Right.
going to say, nobody's going to take it on a whim, right?
No.
The only people who are going to take it are the ones who are, you know, have an interest in it in some
Right.
way, shape, or form.
Right.
So your results are going to be skewed there when you ask that.
Right,
you know,
and
question,
probably 2/3 of the kids, you know, yes, they own a soldering iron, something like that.
Yeah.
I mean,
See,
it
that's
varies a
crazy.
lot.
You know, in my experience in general engineering degree and other engineering courses, like it's down around the 1% mark.
Really?
Right. It is.
Oh.
Yeah. It's practically no one. Right.
Yeah.
Has
Well, a lot
any
less than it used
interest
to be, I
in
think.
hobby electronics. You know.
You know what
It's-
I always wonder about? I mean, I've even asked non-technical people. I say, how can you go through life not being totally obsessed with wondering about certain things, like why are all those wires hanging off telephone poles and stuck in the ground? You know, what are they for?
Yeah.
You know, there's obviously not electricity in them. Why
Where's
are they
your
there?
natural human curiosity?
Right,
you know?
like why
Yeah.
do you have something coming out of the wall, maybe, and it makes things go around? I mean, like, how does that happen?
Yeah.
You know, I just can't believe that doesn't drive. Like, you know, the old bit about religion came from the fact that they couldn't understand.
Yeah.
You know, early people couldn't understand, say, lightning, so they made something up. Well, it's sort of the same thing. Aren't you fascinated by all these things around you?
Right,
You know?
right.
Yeah, I can't believe that the biggest cable television network is not a science channel.
That's
You know,
right.
Why?
That's
it's
right.
so fascinating.
Yeah.
You know?
Well, I think my conclusion is that the ones that do wonder about these things are the ones that become engineers and then good engineers. I suppose that's it.
Right.
You know,
I think the real question is when they do it too, because I mean, I think that people who ask that and have the facility to do it earlier in life, they become hobbyists as they're growing up, right? And some kids just don't have that, and then they go to college and say, "Oh, I'm curious about electronics, or I'm curious about electricity," and then they
yes,
jump
there's
in, right?
always staging. But here's the question: does Lego Mindstorms count?
Ooh, that's a good question.
Does that
Yeah,
really
you know.
count as hands-on tinkering? I'm not sure.
Well, it's better than nothing. I mean,
You're absolutely right.
Right.
I should go around to garage sales and see how many show up at garage sales. Do people give up, and do they
kick-out
really
rate,
keep
yeah.
them?
Yeah.
I don't know. It just, you see barbells laying or exercise machines on the sidewalk all the time.
Nordic Track.
Well,
Nordic Track, a lot of
there's-
Nordic Track. But I don't see Lego Mindstorms, so I don't know.
Well, there's
But
the same debate going on with the Arduino, for example. Is that, hobby electronics, or is that just, people...
Well, I will tell you
know,
something. We had a debate on the process. We wanted to have a digital side on this freshman course, and I decided the Arduino would be the way to go because probably a certain percentage of the kids would be familiar with it. Plus, you can buy it at Radio Shack, and maybe there's some longevity there.
There's practical reasons to.
And I had the exact same argument that Dave did. I didn't like it at first, and then eventually I said, who cares? People are working on electronics. That's all that eventually matters,
It's better
right?
than nothing.
And the ones that want to work with analog will go towards analog. The ones that want to go towards FPGAs.
Why didn't you like it?
I thought it was copping out at first, but that was stupid, right? I mean, I thought it was...
Well, at least it uses C. I mean, Lego Mindstorm...
It uses modified C. It uses wiring, but I mean, yeah.
But there's also the pickaxe.
Right.
That uses BASIC.
Yep.
Oh, I didn't know that.
Yeah, and
yes,
so
it does.
there you have something that a junior high school kid could have a great amount of fun with.
Right.
And maybe get excited
right.
about.
And that's what it came down to for me is, if people are doing electronics, it doesn't matter. Whatever works.
The people that do, who stay in the digital field, of course, have no concept of what it's like to get a complicated analog circuit to work. I mean, it's just worlds apart.
Right, but
worlds apart.
I think, I personally, some digital stuff just right over the head.
Same with me. I agree.
I know, exactly.
No
I was going to say,
question
some, complex FPGA stuff is, you could say, orders of magnitude more complex than trying to get an analog, control loop working, right?
Try PowerPoint. I mean, I really have problems. But it's all, it's all your history and what you like and just what tickles your fancy, I guess.
So we're all pretty much agreed here. There's a consensus that it doesn't matter as long as you're doing something, right?
Right.
Yes.
Doesn't matter what it is.
And who are we to say?
Doesn't matter what floats your boat.
Right.
As long as it somehow involves electricity.
Right. But I do, it's in my department and a lot of universities, electrical engineering and computer science. And so I try to tell people, if you're going to know software, but if you know hardware, just interfacing and things like that, my goodness, you're so much more valuable,
That was a question on the forum that popped up yesterday, actually, on the EEV blog forum. Somebody asked, I've done my computer, my IT degree. Should I do another 2 years master's in computer science / IE software, or should I do EE? Right? And I said EE would make you a much more valuable,
absolutely
employee.
In a small machine environment, like a microprocessor or something, what are you going to do with it? It's got to light a light bulb or turn a motor on or something. I mean, there's got to be interface and hardware and all that. It's not like you're sitting as the IT person in a law firm, where admittedly you probably don't need to know circuit design. But to make anything, again, in a small system, you really have to know hardware. And people are probably
I just figured,
doing it
why
that
do
don't,
another 2 years of software when you can learn hardware? Woohoo! Yet another completely valuable skill set. Different too.
And look at all the people who started out as psychology majors who are phenomenal computer programmers. The point being that, I'm not trying to demean it in any ways, but it's a lot easier to progress in software on your own than it is in hardware.
Yes, because probably the majority of hardware people can at least program.
That's right, but not the other way around.
But not vice versa.
I never thought about it that way. Yes, you're absolutely right.
Yeah.
So,
I'm sure we're going to have some software people up our butts.
I know.
We're like three hardware guys are like, hardware. But...
Yeah, but, have them work out the grounds on a 5 megahertz switching power supply and call me in the morning.
Oh, boy.
Yeah.
We could talk for hours about this sort of stuff, and
And we
get into way too many arguments, I'm sure.
We should...
I think our time is well and truly up. Larry,
it is.
We'd like to thank you for joining us. It
was
awesome.
Great. It was a lot of fun. I've been looking forward to it.
Yeah.
And I hope your listeners enjoy it.
I'm sure they will. The many, many thousands of our listeners.
All right.
Yeah, and we will definitely post information about ThinkBox, which is definitely a very interesting development, and some of the historical stuff about Hexagram, because there actually is shockingly little on the internet. So I don't know if that's by design, but
well, the company changed.
The changed names, right. So
I've got one last question. I always do it. Sorry, it just popped in here. Did you ever give a thought to moving interstate? Move into Silicon Valley or something like that? Why have you stuck around in Ohio?
Well, first of all, how many design and build companies were there in Silicon Valley?
Yeah. Pure competition, right?
Yeah, of course. Right. Yeah.
Yeah. Was there any temptation to move at any point because
no,
for some reason, customer reasons, or
no, absolutely no reason.
Okay.
And remember, we were looking at that time at least at sort of an industrial customer base.
Yeah.
Design and build in Silicon Valley is sort of Coles to Newcastle.
Yeah, okay.
But we made stuff for testing springs and just the car wash control, for example.
Right.
So there's business everywhere.
Got it.
And now there's definitely business everywhere.
Right.
So
and now with communications, everywhere is everywhere.
Right.
Awesome. Well, thank you very much, Larry.
Hey, it was a lot of fun.
It's been great.
Nice talking to you, Dave.
Yeah. Well, thank you, Larry. First guest in the Chris Campbell's basement, but
all right.
Hopefully not the last.
I like the waiting room. That was particularly nice.
How can people follow you in quote marks? Do you have a Twitter account?
I hate to say it.
Are you that modern?
No,
you hate it?
Remember, I'm an analog guy.
Right, okay, right.
Carrier pigeon.
They can just email me. Very simple. Sears.
Mail with a stamp and a
email.
Oh wow!
I'll say this though.
Very progressive.
I never touch paper. I will tell you that much.
Nice.
But anyways, it's Sears, like the store, at case.edu.
Great. All right. Well, thank you again, Larry.
All right. My pleasure.
See ya.
We're having some strange noises back there.
Yeah, that's the Dave baby.
Oh, okay. Sorry, It's not that strange.